This is a introduction to some of the key ideas in linear perspective. Linear perspective is the primary system of drawing that we are focusing on in this course. It is the way that images look like some kind of objective record of physical reality, something similar to a camera sourced image. One of the characteristics of linear perspective is that it has a distinct and fixed point of view, like a camera. Think of a camera on a tripod. If you are drawing from direct observation in linear perspective, or even if you're inventing a scene that obeys the rules of linear perspective, you as the viewer and as the artist, you as the artist and then the viewer is implied, has a fixed point of view, like you are like a camera on a tripod, like a one-eyed camera on a tripod. You're not swiveling your head around, you're not moving around. Every single thing within the page is seen from the same point of view. The other basic idea of linear perspective is that instead of treating the paper as a piece of paper, as a flat surface that is then marked upon, it is the word is illusionistic. It creates the illusion that this rectangle of paper acts like a window onto a three-dimensional reality that in your imagination you could actually step into, and you can understand the relative sizes and placements of objects in that space. So a point of view is one of the characteristics that precedes any linear perspective drawing. And then there are a couple of other ideas. Oh, I didn't write down the horizon line. So the horizon line is not even a line necessarily. It's not even visible necessarily, but it's always implied. And the horizon line represents the eye level of the artist. And again, also the eye level of the viewer of the finished picture, the level from which this image is being seen. So the horizon line is always at eye level. The point of view is always fixed, so eye level doesn't move around in a single drawing. The vanishing point is something that appears on the horizon line. Again, it's not always a visible thing in a drawing. It can just be a sort of invisible structure. And there can be multiple vanishing points in a single drawing. But we're going to start by talking about a drawing that would only have one vanishing point. And that's called single point perspective, logically enough. Sometimes that's also referred to as parallel perspective. And this is because all of the edges of horizontal edges of objects and rows of things are receding, are parallel, and they're receding to one vanishing point. So you perhaps can see, I made some lines here that are kind of radiating out of a vanishing point all over the page. I used a hard graphite pencil, so they're fairly light. I don't know how visible they're going to be on screen, but I just want to sort of demonstrate a single point perspective. Single point perspective purely is something that you don't use that often and you don't encounter all that often in drawings, but it's essential to understand. And you will have seen some drawings in single point perspective. Any kind of image like looking down a road or looking down a railroad track or something like that is almost always a single point perspective drawing. So let's in fact imagine one. Let's imagine we've got a railroad track, and both edges are receding toward the same vanishing point in the center. And I'm doing this very fast and very sloppily. But even with my sloppy method, you can kind of see how this would be receding toward the distance. And also notice that not only do these edges get closer together as we move toward the distance, but these cross beams in the railroad track get closer together as we move toward the distance. Now let's imagine that we have a stand of trees here at the side of the railroad track. So I'm gonna call that a tree. not much of a tree, but it'll do the job, I hope. And you see, I'm using these lines as guidelines to create this illusion that they'll get smaller as they get toward the vanishing point. I guess that's enough of them. Can you see how there's a sense of these trees, or whatever the heck these are, getting in a row, being objects that are the same size roughly, but that they appear smaller and they move to the distance. And again, you can see how the line that would connect the tops of these points to that vanishing point. The line that would connect the bottoms of these points to that vanishing point. Now, just to show you how powerful the illusion is, if I were to take this shape here, the biggest one we've got, right, the one that's in the foreground, and move a shape that big down here, so that would basically go all the way off the page. So suddenly, let's see if I have an eraser here. Okay, it's sloppy, but you can tell what I'm doing. Suddenly this looks like a supergiant tree, right? Or a whatever, carrot, whatever it is. And so it's a supergiant tree, but it's really the same size shape, maybe even a little smaller than the one in the foreground. But because of the relationship that's set up in terms of the system of linear perspective, we understand that same size objects appear smaller as they get further and further away. So for something to be way up here, it must be huge compared to all these other objects, because it's so much larger than the ones that are adjacent to it. An important idea that I introduced in class is that, and I think in the previous video, is that vertical lines, vertical edges in the world, most of the time, can be used as vertical edges in your drawing. It can just be a vertical edge that's parallel to the vertical edge of the paper. There is the exception of what's called three-point perspective, which we're not going to talk about today. So unless you're very, very close to the object, doing a kind of bird's eye view or a worm's eye view, verticals in space, you know, the place where the walls come together, or the edge of the building, or, you know, whatever it is, can be translated as a vertical line on the drawing. And so let's imagine we're making some kind of buildings here. You can see how The bottoms of the buildings point toward the vanishing point, because these are all parallel. The bottom of the building, the top of the door, the windows in the building, the tops of the building. Now, the bottom of these windows are pretty much exactly horizontal. And what does that tell us? They're even with the vanishing point. The vanishing point is on the horizon line. The horizon line represents eye level. So the only place in a situation like this where you would see a truly horizontal line is when it's right exactly at eye level. Lines that begin above your eye level and point down toward the horizon, point down toward the vanishing point, those are going to point down, right? They're going to point in that direction. Lines that begin below are going to point up toward the horizon line. So that's a good fact to know. It'll help you to sort of check your work. So if we went up even further here, we'll find that because this is even further above your eye level, that's going to point down at a more acute angle. So we could keep going. We can find more doorways, more windows that are right at the eye level, although that's not something you necessarily do find. We can have more windows up here where the angles are going to be even sharper, right? And on we go, with more, right? So I hope this is enough to get the idea of the single point perspective drawing across. And then you should look at the next video, which will be about oblique or 2-point perspective drawings, which will be what you are doing primarily in the next homework assignment.